Hey there, I'm Daniel. I'm here with Andrew, and we're here to talk a bit about our character chatbot.
So the goal for a chatbot is to build interactive models that act like specific fictional characters from movies or TV shows. We also have a web UI such that if somebody wants to talk to this character, they can go on our UI and pick their character and then open up a dialogue with their desired character.
So, before we get into the meat of our work, I wanted to quickly run through some related work that, in a way, really motivated us to pursue this specific project because we didn't really see anything out there for our specific use case. And Circle Labs does have this really interesting model where it's designed to play a character, but it has some problems believing it's quote unquote believing that it's a specific character from a specific fiction. Rather, it'll like be very good at emulating general personas. So that brings uh, us to our current work, where we're working on a model where we can emulate a specific character from a specific series.
So our main method is to use GPT-3 as a baseline model to have dialogues between characters, and then we fine-tune it using data from those movies and TV shows. So the main data set we use is Cornell Movie Dialogue Corpus. It's 300K lines of dialogue from various movies. It also contains metadata about combos, the character metadata, and so on. So it's very useful. We picked the Star Trek movies from it because a lot of movies they only contain 2 to 3 hours of content. The Star Trek movies combined together contain more than 10 hours of content. Star Trek also has a very well-defined fandom to get character descriptions from, and they're also more fleshed out. So from the Star Trek data, we generate prompt response pairs, with prompts being character descriptions plus a certain portion of the conversation. The response is the other portion of the conversation indicated by the corpus metadata. So with regards to evaluation methods, we did a lot of our preliminary evaluation on light models because they also generate dialogue. And then we port these evaluation methods over to our Star Trek model.
So now I'm going to talk a bit about the interactive layer that's wrapping our model, which is the chat web app. It's a really lightweight web app that uses both React and Flask, with React on the front end and a Flask backend that wraps the OpenAI Python client library, which ultimately is calling our fine-tuned models via OpenAI's API. So on the right here, I've got this example chat between the user, which is pretending to be a soldier, and our bot, which is pretending to be a wizard. And as you might be able to tell from the conversation, the wizard kind of got some ideas about like his position and what he could do, which may not be so great for the soldier, but it is great for us because I think it really shows the power of our model and the experience that you can get from interacting with it. We've also got this sample conversation here that we also generated through our model between Kirk, which was the user, and Spock, which is pretending to be the bot. And what's great about this example is that we got a lot of specific details that you would only really get out of a Star Trek setting, like characters talking about the language Klingon, and also specific places and like proper nouns like Romulus. So again, I think this was a really great showing of the capabilities of our model.
And here we come to our evaluation. So we mainly use two metrics of evaluation on our model, blue and perplexity. So if you notice, the blue for GPT-3, the two models higher and the perplexity is lower, so it more closely resembles the what is trained on. And the furthermore, these this shows that there's a significant difference between the Unto model and our trained out model. So there is some effect. So regarding further work we could do in this project, there are three main areas. One is to train on higher quality dialogue. The other one is to automate character descriptions, and the third one is to find settings of dialogues, like the location they're in, and include them as visual information. So all three of them are designed to give better data for discussion, in the sense that they're either decreasing the amount of poor data, like dialogue saying yes, no, and then increasing more relevant data, such as character descriptions and setting descriptions. So yeah,
Right.
this is the presentation.
Yeah, thanks for tuning in, and we hope everyone has a good day.